Hello! In this video, we'll be looking at an argument for God based on the existence of the laws of nature. This argument is structurally similar to the psychophysical harmony argument, and so I find it quite powerful. The main difference is that instead of focusing on the fine-tuning of the psychophysical laws, this argument is based on the fine-tuning of the plain old physical laws. Now, this argument isn't based on the fine-tuning of the physical constants, but more so that there even are laws of physics in the first place. I'm not sure if it's more accurate to call my formulation of this argument a nomological argument, or an argument from Temporal Order, or an argument from Induction, but for the purposes of this video, I'll call it the nomological argument. Interestingly, I think one can, in a way, also connect the nomological argument with the argument from the Applicability of Mathematics. We'll look at that at the end of the video. With that out of the way, though, let's jump into the argument. We'll start by observing that our physical universe obeys certain regularities or laws. Whenever an object is dropped, it falls down. Whenever gunpowder is exposed to a flame, it ignites. Whenever glass is hit with a hammer, it shatters, and so on. My question is, why is it that our universe obeys these laws? Now, you may be tempted to answer by pointing to more fundamental laws, like the four fundamental forces explain why objects fall and why glass shatters, and so on. But this just kicks the can up the road. Now I'm just going to ask, why is it that our universe obeys these more fundamental laws? Here's one possible answer that's very David Hume-like. There is no explanation as to why the universe obeys these laws. You want an explanation? Too bad. There isn't one. There's no deeper reason as to why glass shatters every time it's hit with a hammer. It's just what happens, and that's that. End of story. Now, let's assume for illustrative purposes that all naturalists are committed to this view. They aren't, but let's pretend for a minute that they are. Now, this is going to give the naturalists a very big problem. Let's consider two imaginary universes. The first one is like ours, where every time something is dropped, it falls downwards. In the second universe, dropped objects fell downwards every time until today, but after today, they just float in midair. Now, we would want to say that the epistemic probability of the first world is higher than that of the second world, because we tend to think that gravity won't randomly stop working tomorrow. But it seems the naturalists can't say this. They would look at the first world and think, in all of these cases, dropped objects fell downwards. Does this give me any reason to think that dropped objects will fall downwards in the future? Nope. Since there is no reason the object fell downwards in the past, according to my theory, I myself have no reason to expect that it will fall downwards in the future. True, I have no reason to expect the object will float in midair either, but this just means these scenarios tie in terms of probability. Both of these scenarios seem equally likely to me, and I have no reason to expect any particular kind of outcome at all. Here's another way you could illustrate the idea behind this naturalist's reasoning. Imagine a big set that includes every epistemically possible universe. This includes every way of filling out the universe's timeline with physical states, no matter how weird it may look. This set includes our universe, it includes ones where gravity stops working tomorrow, and it includes chaotic universes that radically transform in crazy ways every moment. As an example of a chaotic universe, imagine a world where one moment there are 17 particles in existence, the next there are 80 million particles, then there are none, then there's a black hole, then there's a turtle, and so on. So we have this big collection of epistemically possible universes. If you thought there was some feature of reality that made universes look orderly, then you would assign a higher probability to orderly universes. But we've assumed the naturalist denies that there is such a feature of reality. So they would assign roughly the same epistemic probability to all epistemically possible universes. A very important point here is that there are way more epistemically possible chaotic universes than there are epistemically possible orderly universes. A quick illustration, if I throw a ball up in the air, only one possible path would follow the laws of gravity. But there are a bajillion different paths that would violate the law of gravity, and every outcome of the ball's throw would be in that big set of universes. This means that if a naturalist doesn't predict any particular universe, then it's not like the chance of an orderly universe is 50-50. No, by the naturalist framework, the chance of an orderly universe would be astronomically small. Okay, but enough about naturalism. What about theism? Well, if an orderly universe can bring about more good than a chaotic one, then theism predicts an orderly universe. And an orderly universe can be beautiful and can serve as a public forum for moral agents to interact in. That's us. A chaotic universe can do none of these things, so theism predicts an orderly universe, like ours. Now, you may wonder if theism predicts the existence of a physical universe at all. I'll be covering that issue when I delve into arguments against theism. Right now, we're just asking if there is a physical universe, what would we expect it to look like on naturalism and on theism. Since we have an answer to that question, we can now set up the probability space to reflect what these two theories predict. Naturalism predicts a chaotic universe, and theism predicts an orderly universe. When we update on the fact that the universe is indeed orderly, the probability of theism skyrockets while naturalism's probability plummets. Coolio. Now, you may be worried that I never factored in simplicity into my calculations here. Shouldn't simpler universes get a higher probability? And wouldn't simpler universes tend to be more orderly? We will take a look at simplicity considerations soon, but first I want to address the assumption underlying this argument, that naturalists are committed to saying there's no explanation for the regularities in our universe. Maybe the naturalist can posit a thing, let's just call it X, which isn't God, yet nonetheless explains the order and regularities in our physical universe. Like maybe X is the properties of physical matter itself. Like protons have the property of being positively electrically charged, and this property explains the law, all protons repel each other. Or maybe X is an abstract object that somehow imposes order on our universe. Or maybe it's something else that's just super vague and mysterious. Well, this in of itself won't help. Instead of some X that imposes order on the universe, we can just as easily imagine a different X that imposes chaos on the universe. Such as physical matter with properties that produce chaotic universes, or an abstract object that imposes chaos instead of order. Whatever feature of reality that's posited to explain our universe's tendency to look the way it does, we could come up with a parity that would have a tendency to a chaotic universe. And just as there are more epistemically possible chaotic universes than orderly universes, there are more ways to posit an X that brings about a chaotic universe than an X that brings about an orderly universe. Because we could formulate an X that brings about chaotic universe 1, or an X that brings about chaotic universe 2, and so on. So we're back to square one. If you posit a non-God entity that makes the universe look some way, it would, in all likelihood, make the universe look chaotic. However, a promising response to this line of thought is that we should give a simpler X a higher probability, and simpler X's will tend to be orderly and follow laws. This is why I wanted to hold off on discussing simplicity considerations earlier. I wanted to show that no matter what route a naturalist takes, they will need to use simplicity to assign smaller probabilities to chaotic universes. Now, the problem with this maneuver is that it overcorrects, so to speak. Our universe isn't a chaotic jumble of random physical states. However, our universe is by no means simple either. Here, I'll give you some examples of simple physical universes with simple laws. Here's a universe with a particle that just sits there and does nothing. Here's a 2D universe that's completely empty. Here's a 4D universe that's completely empty as well. Here's a 1D universe where particles just all move to the right at a constant velocity, and so on. We can come up with countless examples. Not only are these universes simple, but if we wanted to posit some X that is imposing the regularities, that X would be really simple too. Compare those universes to our own. Relatively speaking, we have ridiculously complex laws, like those in general relativity and quantum mechanics. If we were to assign epistemic probabilities to universes based on the simplicity of the laws governing them, our universe would once again have to be given an astronomically small probability. So, once we take into account considerations of simplicity, naturalism goes from predicting a chaotic universe to predicting a simple universe where nothing interesting happens in it. Theism, however, remains unchanged. A simple universe would not be able to attain those goods I mentioned, like beauty or serving as a public forum for moral agents. So theism still predicts a complex universe like ours. So we could redraw the probability space. Naturalism strongly predicts a simple universe. Theism predicts a relatively complex, but not chaotic, universe. We update on the fact that our universe is indeed complex, but not chaotic. The probability of theism skyrockets and the probability of naturalism plummets, once again. Coolio. I think it's useful to imagine universes sitting on a spectrum from simple to complex, all the way to chaotic. The universes in the middle there are the best for promoting various goods, and so that's what theism predicts. Naturalism doesn't have this directedness towards goodness, so the best naturalism can do is predict one of the extremes. But we do live in a complex universe, rather than a simple one or a chaotic one. This is powerful evidence for theism. Now, let's look at some objections. The first objection I want to cover is that maybe the laws that govern our universe actually are simple, and we just can't see that. We know that simple laws can lead to complex behavior, so maybe that's what happened with our universe's laws, and we were too hasty to give it a small probability. This objection doesn't work, because it fails to appreciate that we're discussing epistemic probability. Allow me to illustrate. Imagine we're some scientists discussing how we expect a physical experiment to behave. We somehow make a list of every possible way that the experiment could unfold, and assign higher probabilities to the behaviors that could be described by simple laws. Then I pick some random complex behavior and say, maybe this complex behavior here is actually describable with super simple laws, and so we should give it a higher probability. Well, fine, you say. Maybe this complex behavior is actually describable by super simple laws. But maybe this complex behavior is describable by super simple laws. Or maybe that complex behavior is describable by super simple laws. Can you give me any specific reason, prior to us actually performing an experiment, that would lead you to believe that the specific complex behavior you're talking about would be reducible to a set of super simple laws? If the answer is no, then we can't give that specific complex behavior a higher epistemic probability than any other complex behavior. What this shows is that when we're setting up the probability space, prior to updating, the sort of simplicity that matters is the sort of simplicity that we can see. And even if there is some super simple set of laws that underlie general relativity and quantum mechanics, we can't see what they would be, and so this consideration doesn't affect the nomological argument whatsoever. Here's another objection. Can't we apply all this stuff to God's own mind too? Isn't God's mind fine-tuned so that it falls in the middle of a spectrum between a mind that's too simple to do anything interesting and a mind that's so complex that it's chaotic? This is literally the exact same objection as psychodivine harmony discussed in the last video, so I won't be spending too much time on it. That being said, I do want to assign a higher probability to a simpler version of God. Given the view of simplicity I've defended in the series, the simplest version of theism is one wherein God is the most good thing possible, because such a view is the most conceptually unified, so to speak. It's simpler for God to be the best in every respect than for God to be the best in some respects but not the best in others. So, a view where God's mind is chaotic, or even a view where God's mind has nothing interesting going on in it, is a less simple version of theism. I want to buy simple versions of theism because it gets me an awesome view of God, which in turn predicts the particular level of complexity in the physical universe that we do in fact see. One might also object that if God can manipulate the psychophysical laws, then he can make the physical universe look like whatever he wants, whether it's chaotic or overly simple, and then just make the psychophysical laws map that universe to whatever mental experiences are needed for moral agents to interact in a public forum, such as our current experiences. In response, I'd point out that it seems like knowledge is a good thing, and being deceived is a bad thing. And in such a scenario, it seems like we would be radically deceived about the nature of the world we're living in. Furthermore, it seems like this sort of scenario has less beauty and aesthetic value. So, theism predicts that we would live in a universe that more or less matches our experience of the world, rather than a chaotic world or something. Lastly, what if we posited a multiverse wherein every possible universe existed and then applied some sort of anthropic principle? How does this affect the argument? Well, since every possible universe is in this multiverse, then this multiverse includes universes that were chaotic up until 1 millisecond ago, and then randomly produced your brain, and then will continue being chaotic after 1 millisecond. Since there are more ways to be chaotic than orderly, most universes that include an appearance of a brain will look like this. So such a multiverse entails that you probably are just a blip in a chaotic universe, like a Boltzmann brain. This runs into all sorts of problems. For example, your experiences would in all likelihood be chaotic in such a scenario. So we can conclude that we don't live in such a multiverse. Okay, with all those objections considered, what score do I give this argument? Well, this argument is based on the data that the laws that govern our universe are very fortunate, roughly speaking. Let's use P to denote the number of epistemically possible states of a physical universe. The number of epistemically possible physical laws is the number of ways to pair every physical state with some other physical state. That's P raised to the power of P. So if we don't factor in simplicity considerations, the strength of this argument would be roughly P raised to the P. Rearranging, we could see that this is almost as strong as the psychophysical harmony argument. However, this is probably an overestimation of the nomological argument's strength, because simplicity considerations would give orderly laws of physics like ours a probability higher than 1 in P raised to the P. However, our laws are still insanely complex, at least they are from our epistemic vantage point. So the probability of laws like ours is still going to be super low, even after factoring in simplicity. My subjective estimate of the psychophysical harmony argument's strength was a Googleplex, so I think a good value to assign the nomological argument's strength is a Google, because this shows how I find this argument a good deal weaker than the psychophysical harmony argument, but it's still nonetheless insanely strong, especially compared to the rest of the arguments in philosophy of religion. It should be noted that the reason that I give the psychophysical harmony argument and the nomological argument such high scores is that fine-tuning arguments, by their very nature, are going to be super duper strong in a Bayesian framework. Oftentimes, arguments for and against theism boil down to a difference in intuition, and the evidential support from intuition can only be so strong in these cases. However, whenever fine-tuning crops up, we can argue that the probability of a certain phenomenon given naturalism is super low on the basis of all the epistemically possible non-fine-tuned outcomes. This doesn't rely on mere intuitive support for the premises, so this creates a possibility for much, much stronger arguments than normal. But as I noted after giving the psychophysical harmony argument its score, it's important to thoroughly scrutinize this argument for other possible objections, because it's a really big deal if an argument this strong actually does go through. Now that we've looked at the nomological argument, I want to quickly assess the strength of the argument from the applicability of mathematics. This argument asks us to update on the fact that mathematics is very useful for describing our universe. So it would go something like, Theism predicts that mathematics would be applicable to our universe for some reason or other. Naturalism doesn't make this prediction, so when we update on the fact that mathematics is applicable to our universe, the probability of theism goes up. Now, there's a lot to be said about this argument, but the point I want to make is that the fact that we're updating on, that math is applicable, is actually the same as the fact that our universe is not chaotic. It's impossible to have a chaotic universe where mathematics is applicable, because if mathematics was applicable, it wouldn't actually be chaos, and it's impossible to have an orderly universe where mathematics is inapplicable, because we could just describe the regularities of that universe with mathematical expressions. And it seems we can know all this without actually seeing any other possible universe. What does all this mean? Well, when we drew up the probability space for the nomological argument, the areas where we found orderly universes were the same areas where mathematics was applicable. When we updated on the fact we lived in an orderly universe, we scribbled out the sections of the probability space where the universe is chaotic, i.e. where mathematics is inapplicable. So when we stretch back to a square, we find that in 100% of the probability space, mathematics is applicable. So we can't scribble stretch on the observation that mathematics is applicable anymore. You see, the nomological argument and the argument from the applicability of mathematics are secretly based on the same data, just packaged differently. So, as far as I see it, when we run the nomological argument, we can't run the argument from the applicability of mathematics as well. That would be double dipping. Anyways, that's the end of this video. Thanks for watching. I'll see you in the next one.